Good day, everyone. Today, we will discuss Quarter 1, Week 2 in Mathematics 9. I am Miss Jenna H. Raagas, Teacher 1 from Pililla National High School. Are you ready to learn? So let's start. Our topic is about characterizing the roots of a quadratic equation. For the most essential learning competencies, we have characterize the roots of a quadratic equation using the discriminant. Let's have a short activity. The direction here is to write the following quadratic equations in standard form: ax squared plus bx plus c is equal to 0. Then identify the values of a, b, and c. Number 1, we have x squared plus 5x is equal to 4. What did you notice on the given? Good job! The given is not yet in standard form, so let us transform it. So let us copy the given, and then we will transpose positive 4 to the left side of the equation. So let us copy x squared plus 5x. So from positive 4, it becomes negative 4 is equal to 0. Now, since the given is already in standard form, let us now find the values of a, b, and c. A is equal to the numerical coefficient of the first term, which is 1. B is equal to the numerical coefficient of second term, which is positive 5, and C is equal to negative 4. Number 2, we have 10x minus 1 is equal to 4x squared. As you can see, the equation is not yet in standard form. Therefore, we will also transform it. Let us copy the given. So we will transpose 10x to the right side and negative 1. Let us copy 4x squared, and so from positive 10x, it becomes negative 10x. And from negative 1, now it becomes positive 1 is equal to 0. Now, let us find the values of a, b, and c. A is equal to positive 4. B is equal to negative 10. And C is equal to positive 1. Next, for number 3, we have 8x squared plus 5 is equal to 0. So the given here is already in standard form. So no need to transform it. So let us copy the given. And then we will find the values of a, b, and c. A is equal to 8. B is equal to 0. Why? Because, as you can see in the given, there is no second term. So it becomes 0. Next, C is equal to positive 5.
I hope it refreshed your mind.
Now, let us move on to our discussion. In the quadratic formula, x is equal to negative b, either positive or negative square root of b squared minus 4ac all over 2a b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c is equal to 0. By knowing the value of b squared minus 4ac, we can now determine the nature of roots of a quadratic equation. Next, let us look at the table that shows the possible values of the discriminant b squared minus 4ac and the nature of the roots. If b squared minus 4ac is equal to 0, the nature of roots are real numbers and are equal. If b squared minus 4ac is greater than 0 and the perfect square, the nature of roots are real, rational, but are not equal. If b squared minus 4ac is greater than 0 but not a perfect square, the nature of roots are real, irrational, and are not equal. And lastly, if b squared minus 4ac is less than 0, the nature of roots are imaginary, or there are no real roots. To fully understand, let's have an example. Example number 1 is to describe the roots of x squared minus 4x plus 4 is equal to 0. First, we must find the values of a, b, and c of quadratic equation x squared minus 4x plus 4 is equal to 0. We have a is equal to positive 1, b is equal to negative 4, and c is equal to positive 4. Then, we will substitute these values of a, b, and c in the expression b squared minus 4ac. Let us write b squared minus 4ac is equal to, let us substitute the values of a, b, and c. Okay, the value of b is negative 4. So it becomes quantity negative 4 squared. Copy the operation, which is subtraction. And then copy 4. And then substitute the value of a, which is 1. And then the value of c, which is 4. So it becomes quantity negative 4 squared minus 4 times 1 times 4. So let us now simplify. So it is equal to, quantity negative 4 squared is equal to 16 because negative 4 times negative 4 is equal to positive 16. Copy the operation, which is subtraction. And then we have 4 times 1 is equal to 4 times 4 is equal to 16. Therefore, the discriminant is 16 minus 16 is equal to 0. Okay. Since the value of b squared minus 4ac is 0, we can say that the roots of the quadratic equation x squared minus 4x plus 4 is equal to 0 are real numbers and are equal. So to see if the roots of the given quadratic equations are really real numbers and are equal, let's try to check. Okay, so here is the given x squared minus 4x plus 4 is equal to 0. So here, we will use factoring method. So to factor, let us find the factors of the third term, which is 4. What are the possible factors of 4 that when you add, the answer is the second term, which is negative 4? So let us try to find. So we have 4 is equal to 4 times 1. We have also negative 4 times negative 1. It is equal to 4. And we have 2 times 2. It is equal to 4. And negative 2 times negative 2. So which of the following do you think when we add, it is equal to the second term, which is negative 4? Okay, very good. The factors are negative 2 times negative 2. So let's check. Negative 2 times negative 2 is equal to positive 4. It is equal to the third term, right? Now, let us try to add. Negative 2 plus negative 2 is equal to, what do you think? Okay, very good. The answer is negative 4, which is equal to the second term. Therefore, the factors of the given are x minus 2 times x minus 2 is equal to 0. Next, we will equate it to 0. So it becomes x minus 2 is equal to 0. So negative 2 transposed to the right side, it becomes x is equal to positive 2. And x is equal to negative 2, transpose it to the right side. So from negative, it becomes positive 2. So by checking, we really found out that the roots of the quadratic equation x squared minus 4x plus 4 is equal to 0 are real numbers and are equal. Did you understand? Okay, let us move on to example number 2. Example number 2 is to determine the roots of x squared plus 7x plus 10 is equal to 0. The first step is to find the values of a, b, and c of the quadratic equation. So let us now find the values. Let's start with A. A is equal to, positive 1. And B is equal to positive 7. And C is equal to, positive 10. So after that, you will now substitute these values to the expression b squared minus 4ac. Let us now write b squared minus 4ac is equal to the value of b, which is 7, minus, let us copy 4, and then the value of a, which is 1, and then the value of c, which is 10. So it becomes quantity 7 squared minus 4 times 1 times 10. Let us simplify. So we have 7 squared is equal to 49 because that is 7 times 7. And then copy the operation, which is subtraction. And then we have 4 times 1 is equal to 4. And then multiply it to 10, it becomes 40. And then we have 49 minus 40. So it is equal to 9. So the value of the discriminant is equal to 9. So what can you say about the value of the discriminant? So as you can see, 9 is greater than 0 and also a perfect square. Since the value of our discriminant is greater than 0 and the perfect square, then the roots of the quadratic equation x squared plus 7x plus 10 is equal to 0 are rational numbers but are not equal. To find out, let us try to check. So this time, we will use the quadratic formula. So the quadratic formula is x is equal to negative b, either positive or negative, square root of b squared minus 4ac all over 2a. So let us substitute the value of a, b, and c in the quadratic formula. So here it is. So it becomes x is equal to negative 7, either positive or negative, square root of 7 squared minus 4 times 1 times 10 all over 2 times 1. It becomes x is equal to negative 7, either positive or negative, square root of 49 because 7 squared is equal to 49 minus we have 4 times 1 is equal to 4 and then times 10 is equal to 40 all over 2 times 1 is equal to 2. Next, it becomes negative 7, either positive or negative, square root of 9 because 49 minus 40 is equal to 9 all over 2. Next, it becomes x is equal to negative 7, either positive or negative 3. So, since 9 is a perfect square, therefore, when you get the square root of 9, it becomes 3. So, next. Let us separate. So it becomes x is equal to negative 7 plus 3 all over 2. And x is equal to negative 7 minus 3 all over 2. Now, let us simplify. We have negative 7 plus 3 is equal to negative 4. Copy the denominator, which is 2, so it becomes over 2. So, the other one is negative 7 minus 3 is equal to negative 10. And then copy the denominator, which is 2. And to simplify, x is equal to negative 4 all over 2. It becomes x is equal to negative 2. Because when you divide negative 4 by 2, it becomes negative 2. How about the other side, which is negative 10 divided by 2? What do you think is the answer? Okay, the answer is x is equal to negative 5. So, we find out that the roots are really rational numbers but are not equal. For example, number 3, describe the roots of x squared plus 6x plus 3 is equal to 0. So, let us now find the values of a, b, and c. So, we have a is equal to positive 1. B is equal to positive 6. C is equal to, positive 3. Now, since we have the values of A, B, and C, let us substitute it in b squared minus 4ac or in our discriminant. So, let us write b squared minus 4ac. So, now let us substitute. What is the value of b? Okay, the value of b is 6. And then minus, copy the number 4. And then, what is the value of a? Okay, the value of a is 1. And then, the value of c is 3. Next, let us simplify. So, it is equal to 36 because that is 6 times 6. And then, copy the operation, which is subtraction. And then, simplify 4 times 1 times 3, it becomes 12. Therefore, we have 36 minus 12. Our discriminant is 24. So, as you can see, our discriminant is greater than 0, right? But not a perfect square. So, what do you think is the nature of the roots of the quadratic equation? Any idea? The roots of the quadratic equation x squared plus 6x plus 3 is equal to 0 are irrational numbers and are not equal. So, let us find out if it is true. Let us check. So, again, let us use quadratic formula. So, we have x is equal to negative b, either positive or negative square root of b squared minus 4ac all over 2a. So, since we have the values of a, b, and c, let us substitute it to the quadratic formula. So, it becomes x is equal to negative 6, either positive or negative square root of c squared minus 4 times 1 times 3 all over 2 times 1. Next, we have x is equal to negative 6. We only copy. And then either positive or negative square root of 36 because that is 6 is squared. 6 times 6 is equal to 36. And then minus, we have 4 times 1 is 4, and then times 3 is equal to 12. And then we have 2 times 1, it is equal to 2. Next, we have negative 6, either positive or negative. We have square root of 24 all over 2. And then, to simplify, since 24 is not a perfect square, we will find the factor of 24 where one factor is a perfect square. We find 4 times 6 as a factor of 24 where one factor is a perfect square. So we copy negative 6, either positive or negative, square root of 4 times 6. So 4 times 6 is a factor of 24. And then all over 2. So let us simplify. So it becomes x is equal to negative 6, either positive or negative 2. Because 4 is a perfect square, therefore the square root of 4 is 2. And then copy square root of 6 all over 2. So now, let us simplify. So we have x is equal to negative 6 plus 2 times square root of 6 all over 2. And x is equal to negative 6 minus 2 times square root of 6 all over 2. So as you can see, we separate the operation. And then, we cancel negative 6, positive 2, and 2. Negative 6, negative 2, and 2. So, it becomes x is equal to negative 3. Why? Because negative 6 divided by 2 is equal to negative 3, right? And then, copy the operation which is addition. 2 divided by 2 is equal to 1 times square root of 6. The final answer here is x is equal to negative 3 plus square root of 6. How about the other side? So we have x is equal to negative 3 because negative 6 divided by 2 is equal to negative 3, and then negative 2 divided by 2 is equal to negative 1, and then copy square root of 6. The final answer here is x is equal to negative 3 minus square root of 6. So upon checking, we found out that the roots are really irrational numbers and are not equal. So let's have our last example. Determine the nature of roots of x squared plus 2x plus 5 is equal to 0. So the first step here is to find the values of a, b, and c. Can you find the value of a? What do you think is the value of a? Okay, a is equal to positive 1. How about the value of b? B is equal to positive 2. How about C? C is equal to positive 5. Now, since we have the values of A, B, and C, let us substitute these in the expression b squared minus 4ac or in our discriminant. So let us write the discriminant b squared minus 4ac. So it is equal to, let us substitute the value of b, which is 2. Copy the operation, which is subtraction, and then copy 4, the value of a, which is 1, and then the value of c, which is 5. Now, let us simplify. So we have 2 squared is equal to 4 because that is 2 times 2, right? And then minus 4 times 1 is equal to 4. And then 4 times 5 is equal to 20. So it becomes 4 minus 20. What do you think is the answer? Any idea? So what do you think is the value of our discriminant? Okay, the value of our discriminant here is negative 16 because 4 minus 20 is equal to negative 16. Since the value of our discriminant is less than 0, because that is negative 16, right? Negative 16 is less than 0, but not a perfect square. So what do you think is the nature of the roots of the given quadratic equation? Since the value of our discriminant is less than 0, but not a perfect square, then the quadratic equation has no real roots, or it is imaginary. Let us find out if it is really has no real roots. So let's check. So now we will use quadratic formula again. So x is equal to negative b, either positive or negative square root of b squared minus 4ac all over 2a. Since we have the values of a, b, and c, let us substitute it to the formula. So it becomes x is equal to negative 2, either positive or negative square root of 2 squared, minus 4 times 1 times 5 all over 2 times 1. So it becomes x is equal to negative 2, either positive or negative square root of 4. So where it comes from? It comes from 2 squared because 2 times 2 is equal to 4. And then we have negative 4 times 1 is equal to negative 4, right? And then negative 4 times 5 is equal to negative 20. Denominator, which is 2 times 1, it becomes, of course, 2. Next, let us simplify. So it becomes x is equal to negative 2, either positive or negative square root of negative 16 because 4 minus 20 is equal to negative 16. And then copy the denominator, which is 2. So now let us separate it. So it becomes x is equal to negative 2 plus square root of negative 16 over 2 and x is equal to negative 2 minus square root of negative 16 over 2. Therefore, it is true that the roots of the given quadratic equation are not real numbers or imaginary.
Remember that using the discriminant, we can easily determine the nature of the roots of the given quadratic equation.
Thank you for listening. God bless us all.